Installing exhaust headers will add extra power from a car's engine. They bolt onto the engine, giving each cylinder its own exhaust pipe leading to the collector, which connects to the car's main exhaust pipe. That's more efficient than having all the cylinders exhaust into a common manifold. A header draws out significantly more spent exhaust gases after combustion, leaving room for a greater amount of new gas and fresh air to enter the cylinder for the next combustion cycle. Headers are made of steel or stainless steel. A worker uses a roll cutter to slice tubes into nearly 6-inch long pieces for the header's collector. A forming tool on a press stretches one side of the collector outward. Then, the worker places the same side on an end-forming machine, which shapes it like a 4-leaf clover. He slips a flange over the unshaped side and widens that side to create the ball portion of the gasketless ball and socket connection to the car's main exhaust pipe. Meanwhile, another worker roll cuts narrower tubes into 32-inch long pieces to make the header's primary tubes, the ones that attach at the top to the engine cylinders. A worker slides a tube onto a mandrel. Then a computer-guided mandrel bender bends the tube in 4 places. The mandrel fills the inside of the tube just up to the bend point, preventing the tube from compressing or collapsing under pressure. The header they're making here is for a 4-cylinder engine, so it has 4 primary tubes. An 8-cylinder engine requires a pair of headers, whereas a 6-cylinder engine requires a pair of 3-tube headers. A worker trims the bent primary tubes to the required length with a bandsaw. The 2 sawed edges of the tube are ragged, so the next step is to grind them smooth. After grinding, the edge no longer looks like this. Workers heat the top end of the tube with a torch to soften the steel. They place the end into an end forming machine. The machine shapes the end to match the top profile of the cylinder to which the tube will be mounted. Cylinder profiles vary from engine to engine, so workers simply change the forming tool on the machine. A worker clamps the header flange with its 4 exhaust ports onto an assembly jig and positions the top end of a primary tube in each port. He inserts the bottom ends into the 4-leaf clover-shaped collector. He then welds the top end of each tube to its exhaust port on the header flange. Then he welds a tag with a company name onto one of the tubes. Finally, he welds the bottom end of the tubes to the collector. The header's 3 sections, flange, tubes, and collector, are now fused. The worker grinds down the weld around the ports until it's nearly flush. The remaining bit of weld material encircling the port will act as a seal to prevent leakage. During the welding, some welding material drips into the header flange's openings. So a worker reams the bolt holes with a drill and grinds the edges of each port. He mounts the header on the corresponding engine cylinder head to make sure bolt holes are sufficiently cleared. Then he runs a torch over all the joints to check the welds. The flame would shoot through any hole in a weld, alerting them to repair it. This factory applies one of 2 finishes on its exhaust headers. The basic one is a coat of black water-based paint sprayed on and air-dried. It prevents surface rust from forming while the part is warehoused. The higher-end finish is an aerospace-grade ceramic coating, available in black or silver. This baked-on finish protects the headers from rust for many years of high-performance driving.